Toyota has been chasing one number for 30 years. 45 PHN-TRM thermal efficiency. They never got there. China just hit 48. In a $9,000 sedan. Guinness flew in, tested it, and made it official. This is not about one engine. This is about who controls the next 50 years of driving. To understand what just happened, you have to go back to 1986. A farmer's son named Li Shufu, born in 1963 in rural Zhejiang province, borrowed $3,000 from his family and opened a tiny factory. He named it Geely, the Chinese word for lucky. He started with refrigerator parts, then motorcycles. Then, in 1997, he announced he was going to build cars. The entire Chinese auto industry laughed at him. He had no factory, no engineering team, no experience. He famously told reporters that a car was just 4 wheels and 2 couches. People thought he had lost his mind. He had not. By 2001, Geely became the first private Chinese company ever licensed to manufacture automobiles. Then in 2007, Li Shufu did something that seemed completely delusional. He sent a formal letter to Ford Motor Company offering to buy Volvo. Ford ignored him. He showed up at the Detroit Auto Show in 2008. Ford brushed him off again. He came back in 2009, and in 2010, the farmer's son from Zhejiang walked out of Ford headquarters with Volvo in his pocket for $1.8 billion in cash. That was not the end. In 2018, he quietly purchased 9.7 PHN-TRM of Daimler, making him the single largest individual shareholder of Mercedes-Benz. Today, Geely's portfolio includes Volvo, Polestar, Lotus, Lynk & Co. and Zeekr, a collection of brands that spans economy cars to supercars, Scandinavian engineering to British heritage. The man nobody believed built one of the most powerful automotive empires on the planet. And in April 2026, he just used that empire to detonate a bomb in the middle of the global auto industry. Before we get to the engine, let's talk about the problem it is solving. Because for the past decade, the auto industry has been selling the world one story. Electric vehicles are the future. Full stop, end of debate. Except the people actually living with electric vehicles are telling a different story. Start with charging. Every advertisement promises fast charging. What that actually means is you sit at a station for 20 to 40 minutes. If the charger is working, if there is not a line, and if you manage to find one in the first place, on a long road trip, that is not a quick stop. That is a scheduling problem. Then there is cold weather. Electric vehicle batteries lose between 30 and 40% of their range when temperatures fall below freezing. The 300-mile range you paid $60,000 for. In a Minnesota winter, you are looking at 180 miles. That is a fundamental physics limitation, not a software bug that gets patched in an update. And nobody puts this in the brochure. When an electric vehicle battery finally degrades past usability, replacement costs between $10,000 and $20,000. That is not a repair. That is buying a second car to keep your first one running. There is also the supply chain problem that rarely gets mentioned in the marketing materials. Electric vehicle batteries require lithium, cobalt, and nickel. Cobalt mining is concentrated in the Democratic Republic of Congo, where documented cases of child labor in mining operations have been reported for years. The environmental cost of extracting these materials at scale is significant, often counteracting the clean energy narrative the vehicles are sold on. And if every American household switched to an electric vehicle tomorrow, the power grid would fail. The Department of Energy has been raising this concern for years. The infrastructure simply does not exist yet. So the question was never really combustion or electric. The real question was, is there a third option? Something that sidesteps all of these problems, without asking consumers to completely restructure how they live. China just answered that question. And the number they put on paper is stunning. In April 2026, at the Beijing Auto Show, Geely took the stage and introduced what they call the iHEV, Intelligent Hybrid Electric Vehicle System. At the center of it is a new engine designated the BA15, a 1.5-liter 4-cylinder, compact, mass, producible, and built for real roads, not racing circuits. The number they announced first, 48.41 phn TRM thermal efficiency. Let that land for a moment. The average gasoline engine in a standard passenger car converts roughly 30 to 35% of the fuel's energy into actual movement. The rest, the majority, disappears as waste heat out of the exhaust pipe. You are paying for energy you never use. That is the fundamental inefficiency that has defined combustion engines for over a century. Toyota spent 30 years refining the Prius powertrain, and eventually pushed their best hybrid engine to 41 phn TRM thermal efficiency. That was considered the ceiling, the number every other automaker benchmarked against and accepted as the outer limit of what was physically achievable in a production vehicle. Geely just walked past it. 48.41 phn TRM does not sound dramatically higher than 41 phn TRM, until you understand what that gap actually represents in engineering terms. Every percentage point of thermal efficiency at this level requires solving increasingly difficult problems. Heat management, combustion timing, cylinder geometry, friction reduction, problems that compound on each other. Going from 41 phn TRM to 48 phn TRM is not incremental improvement. It is a structural rethinking of how an internal combustion engine operates. For reference, Formula One engines, the most technically advanced internal combustion machines ever built, operate at approximately 50 phn TRM thermal efficiency. They cost millions of dollars each and are rebuilt after every race. Geely is now within 2 percentage points of a Formula One engine, in a sedan with a starting price of around $9,000. Guinness World Records certified it, the highest thermal efficiency ever recorded for a mass-produced internal combustion engine. But that is just the engine in isolation. Geely then paired the BA15 with a 308 horsepower electric motor and their AI cloud power management system, an intelligent controller that decides in real time how to split load between combustion and electric power to minimize fuel consumption at every driving condition. The combined system went to a closed test loop in Hainan and averaged 2.22 liters per 100 kilometers. That converts to 106 miles per gallon. Guinness certified that result as well. In 2024, Toyota drove a Prius from Los Angeles to New York, specifically to demonstrate real-world hybrid efficiency. They averaged 92.9 miles per gallon and called it a landmark achievement. Geely just cleared that benchmark by more than 12% in a mass-market sedan. Here is what makes this more than just one impressive headline. Geely is not an isolated case. This is a pattern. BYD, the same company that overtook Tesla in global electric vehicle sales, launched their 5th-generation DM hybrid system in 2024 with a 46.06 phn TRM thermal efficiency. Their vehicles achieve a combined range of 2,100 kilometers on a single tank and charge. That is over 1,300 miles, roughly the distance from Miami to Boston, without stopping for fuel or power. Aeolus, a brand most Americans have never heard of, recorded 45 phn TRM thermal efficiency on their L7 sedan. Changan, SAIC, Chery, and Great Wall have all introduced vehicles in the past 18 months, with combined ranges exceeding 2,000 kilometers. Meanwhile, Toyota and Honda, the brands that defined hybrid technology for a generation, remain at 41 phn TRM in their most efficient production engines. Ford, General Motors, and Stellantis are still manufacturing engines that have not crossed 35 phn TRM thermal efficiency. That is not a small gap, that is a generational technology divide, and it opened up quietly while the American industry was focused on a different argument entirely. And the reach of Geely's technology does not stop at China's borders. Through their Horse Powertrain joint venture, Geely actively licenses powertrain technology to other manufacturers. Geely owns Volvo. They own Polestar. They co-develop vehicles with Mercedes. Benz through the Smart brand joint venture. The iHEV architecture is already being integrated into larger SUV platforms. The Preface, the Monjaro, the Boyer L, and the Xingyue L commercial vehicle applications are next. This technology is not staying in China. It is moving into European showrooms, into joint venture products, into markets across Southeast Asia, South America, and eventually North America. The tariff debates in Washington slow that process. They do not stop it. What China built is not a single engine. It is a new baseline for what a production vehicle powertrain can achieve, and every competitor now has to respond to a standard they did not set and did not see coming. A farmer's son, who started with $3,000 and a refrigerator parts factory, just built the most thermally efficient mass production engine in automotive history. He was laughed at, ignored, turned away at the door of Ford Motor Company twice. He kept building anyway. The future of internal combustion was not killed. It was quietly perfected. And it happened in Hangzhou, while the rest of the world was arguing about charging infrastructure and grid capacity. 106 miles per gallon. Guinness certified. Already in production. The question worth sitting with is not whether this engine is impressive. It clearly is. The real question is what it means for the next 30 years of transportation. And whether the companies that shaped the last 100 years of driving are moving fast enough to stay relevant in the next 10. The future of how the world moves is no longer being decided in Detroit. It already was decided. Most people just haven't heard about it yet.